sensory, one is motor. They can happen at the same time, by the way. Because what kind of nerves are many nerves in your body? Starts with an M. Mixed, right? A mixed nerve. So if that was a nerve is a bundle of what again? A bunch of axons, correct? So how about these are some axons going in that direction, and these are some axons going in the opposite direction, carrying information in the opposite direction. And I'm going to say that the blue ones are the sensory axons, and the red ones are the motor axons. That's a mixed nerve. I think you guys already know this, do you not? A mixed nerve has both sensory and motor function. Okay? And many of the nerves in your body are both. So if you have some type of trauma to a nerve, if you crush this nerve, chances are you're going to damage those and you're going to damage those. So you'll have both a sensory and a motor neuropathy. Okay, carpal tunnel syndrome. Perfect example. Carpal tunnel syndrome, a lot of times you'll have atrophy and weakness of the muscles in your hand, and at the same time, you'll have pain, you'll have tingling, you'll have numbness. Why? Because the nerves that are being damaged are mixed nerves. Now there are instances where it can either be sensory or motor, and most of the time when that occurs, it's some autoimmune condition that's occurring. All right? There are some autoimmune conditions where the immune system just eats sensory nerves or just eats motor nerves. And why does that happen? We don't know. Okay? Are we good? All right, so again, know what a neuropathy is, know what will happen with sensory, know what will happen with motor. And again, this is somatic. Are there autonomic neuropathy? Absolutely. I'm going to talk about that shortly. Okay? Good, guys? Yes? Excellent. Now what are we going to do? We're going to move off of the somatic nervous system and on to the autonomic nervous system. So what I'm going to do first is give it to you in a generalized sense, and then I'm going to take the sympathetic and the parasympathetic separately and draw those pictures separately because there's differences between the two. The other thing, and I think I mentioned this on Monday, is that when we talk about the peripheral nervous system, I want you to be able to compare and contrast the somatic nervous system to the autonomic. And the things that you have to know, I will continuously point out to you. So as I start to draw the autonomic nervous system, I will point out the similarities and I'll point out the differences. All right? Again, the enteric we're going to skip. And then you're going to also have to know, or to be able to compare and contrast sympathetic to parasympathetic. And again, I will point that stuff out. All right? It's blatantly obvious, but I'm still going to point it out to you guys. So what are we going to do first? We're going to take all these words right here, and we're going to draw. All right? That's your autonomic nervous system in a nutshell. So what we're going to draw is this picture, except autonomic nervous system. So at the top of this next picture, we're going to label it autonomic. Motor output, by the way, that's what we're doing right now. Let's not forget, even though I just talked about sensory neuropathy, we're still right now concentrating on this side of the story. But now we're going to do it for the autonomics. The effectors are going to be different. The motor neurons are going to be put together differently. All right, so we're going to see that now. So motor output of the autonomic nervous system. We still have the brainstem and the spinal cord. That's not going to change. Okay, so our central nervous system is in place now. We have our regions of the spinal cord. Now, when I draw these motor neurons, I want you to draw them exactly the way that I do. One's going to be short, one's going to be long, and I'll point it out as I do. This is a soma of a single neuron, and we're going to draw this one long. And the next one, we're going to draw short. I'm going to draw just a teeny bit like this. We're going to draw effectors right there. All right? We're going to draw a few more. Out of the thoracic region, draw the first neuron in its axon, draw it short. Synapse it with another neuron and make that one long. We're going to do the same thing in the lumbar region. The first one, short. The second one, There are exceptions to this rule, by the way, as we'll see a little bit later on in the lecture today. The one in the sacral region will be drawn just like the one in the brainstem. The first one, long. The second one, short. And we have effectors for each of these. And we're actually going to put these boxes here, and we're going to label in each of those boxes because two of them are going to be the same and the other two will be the same as each other. You'll see in just a second. All right? So far, we already see a difference, do we not? What's our huge difference that's blatantly obvious here? We have two neurons in series, correct? Here, there's just one. So I'm going to point this out again to you. I pointed it out to you on Monday. Somatic nervous system. One efferent motor neuron from the central nervous system to the effector. What I've just outlined is this. One efferent motor neuron to the effector in the somatic nervous system. That's different when it comes to the autonomic nervous system. In the autonomic nervous system, two efferent motor neurons between the central nervous system and the effector. Yep. 1, 2. They synapse with each other. Okay? So there's a difference. There are similarities. We're still coming out of the brainstem and the spinal cord. We're still innervating effectors. We're still controlling effectors. Those are similarities. But there's obviously a difference when it comes to there's two here and there's one on the other. It's just the way it is. It's anatomy. All right? What else? We're going to put myelin on the first one of each. The first one is always myelinated. The second one is not. And they're going to have special names, and I'm going to tell you what their names are in just a second. So the first one's myelinated. The one that comes out of the central nervous system, out of the brainstem and the spinal cord, is myelinated. Okay? And we're synapsing with the other one. This is the synapse, by the way. Those are three synaptic terminals, those chicken feet little things, and the circle is the soma of the other axon. And we're obviously synapsing with the effectors here. Now, what are the effectors of the autonomic nervous system? It's not skeletal muscle. Your skeletal muscles are not controlled by your autonomic nervous system. Your somatic nervous system controls skeletal muscles, as we can clearly see. So here's going to be a difference. Another one. What are we controlling here? Smooth muscle. Smooth muscle is muscle that's wrapped around, most of them are, hollow organs. What's a hollow organ? Your stomach, your small intestine, your bladder, your blood vessels. Those are organs that are hollow. They have stuff in them. Blood vessels have blood. Okay? Your bladder has pee in it. Your stomach has food in it. So, they're hollow, but they have stuff, but it doesn't matter. They're hollowed organs, and there's a whole bunch of smooth muscle wrapped around them like a sheet. And that's how your autonomic nervous system is going to control those blood vessels and your digestive tract. Your parasympathetic nervous system is known as what? Rest and digest. Because it plays a major role in controlling your digestive system, as we'll learn next semester in excruciating detail. All right? That's one effector. There's three. Number two, your heart. And we're going to put cardiac muscle. So cardiac muscle is the muscle of your heart. Now it controls other things within the heart as well. We'll talk about that next semester. Okay? And then the last one, the third one, I have cells of the viscera, I think, in the nose. I'm just going to put visceral cells. What's a visceral cell? A visceral cell could be a fat cell, an adipocyte, a liver cell, epithelial cells of glands. So your autonomic nervous system is going to control glands. Your autonomic nervous system is going to control what's going on at your liver. Your organs is what your autonomic nervous system is going to control. Hollow ones via smooth muscle cells, your heart because of the cardiac muscle, and a whole bunch of other particular organs that are made up of these cells. Completely different things. All right? Now I'm going to put smooth muscle here as well. And cardiac muscle, so it'll look just like the one above. The ones on the bottom are going to have something missing. We're just going to put smooth muscle and visceral cells. The motor nerves in the lumbar and sacral region do not go and make synapses at your heart. Okay, just the brainstem, just the thoracic region. So here, smooth muscle and visceral cells. So the bottom two look the same, the top two look the same. All right? What else do we have to know here? We have to know that it's involuntary. So there's another difference. Your somatic nervous system is voluntary. You control your muscles, your skeletal muscles, I should say. You do not control your smooth muscle cells. You do not control your cardiac muscle. You do not control your epithelial cells, your adipocytes. You don't control any of it. You don't control digestion by thought. You don't control your heart by thought. You don't control your glands by thought. Can you do stuff to affect those things? Absolutely you can. But you cannot have a conscious thought and say, I want my heart rate to be faster or slower. You cannot do that. You cannot make your blood pressure go up or down by thoughts. Your yoga teachers might think they can do that, but they cannot. All right? Your sensei might think that they can control these things, but they cannot. Can you put yourself in a relaxed state? Calm yourself. And would your blood pressure probably come down a little bit? Would your heart rate come down a little bit? Yeah. But not because you had a conscious thought to do it. You put yourself in a particular environment that affects the stuff in your body. Can you have an exciting thought right now? You make your heart rate go up. Yes, you can. What's doing that? Your autonomic nervous system is doing it. I'll show you how it does it Monday, not tonight. All right? You do not control any of that. It just doesn't work that way. Okay? But again, what you do, what you think, what you experience, right now, if a big rabid dog comes running through that door down the steps, everybody's heart rate's probably going to jump. Why? Because your autonomic nervous system is going to make it do that. Okay? Automatically, by the way. And that's one of the ways you can think of autonomic. Automatic. It's stuff that just happens automatically. It is adjusting to the environment that you live in and that's inside of you. A lot of it's homeostasis, by the way. All right? So it's involuntary. So far, what have we done? We have controlled visceral cells. Visceral cells, motor output from the brainstem and the spinal cord. It's involuntary. We'll get back to this in just a second. The effectors of motor output, cardiac muscle, smooth muscle, visceral cells, 2 efferent motor neurons between the central nervous system and the effectors. That's what we've done so far. Now what we're going to do is this last part. Preganglionic, postganglionic. The first one and the second one. So we're going to name them. And we're going to talk about exactly what it means. So the first one here is the preganglionic neuron. The second one is the postganglionic neuron. We'll put the word neuron in there. And it's the same. This one's the pre, this one's the post. The pre is myelinated, the post is not. We can clearly see that. By the way, if you haven't drawn up into this point to study for exams, this would be a really good time to start. Okay? Why? Because that picture right there is pretty much what, about 20, 30 lines in your notes? Easily? You can clearly see the preganglionic neuron is myelinated, if that's the way you draw it. You can clearly see that the postganglionic neuron is not. Same thing here. You can clearly see that these motor neurons, those are motor neurons too, we just don't call these preganglionic or postganglionic, you'll see why in just a second, are myelinated. You can see they release acetylcholine. You can see the nicotinic receptors. And we're going to get to the receptors here as well, just not yet. All right? So again, if you haven't drawn up into this point, boy, would this be a good time to start. Okay? So what does it mean, preganglionic and postganglionic? We know what pre and post means, right? Pre means before, post means after. You guys know what a ganglion is, do you not? What's a ganglion? Somebody define a ganglion for me. It's a group of what? It's our body. Where? In the